Welcome to our tutorial of ProfLearn YouTube channel. In this particular video, I want us to have a discussion on Unit 3 Physics of Edexcel IAL Physics. We get to see which are the concepts you really need to understand how to work out as you are preparing for Unit 3, which is Practical Physics 1. This is a paper that you need to prepare, and it's going to test the practical skills that you've been doing in Unit 1 and Unit 2, that is mechanics and also electricity and waves. Now, for instance, here we are provided with a spring, and what you realize is that we have a force meter, we have a rubber band. The student investigated the force needed to break this. So basically this is a stretching of materials, which we learned when we were discussing about Hooke's law and how a rubber band stretch. Then we are supposed, one of the concepts that you need to understand is how to identify safety measures when you are performing experiments. And that is going to really be based on the practical you are given, the scenario and the context you are given in a given question. So in this case, we have a rubber band. So one of the things that can happen is that the rubber band can snap. In the process, it can go straight and hit somebody's eye. So one of the protective measures we can take here is ensuring we put on protective goggles so that in the event this rubber band snaps, the person who's doing the experiment is protected. And also something else we need to notice is that if you are pulling this force meter down, it means that there's likelihood of this particular stand to toppling. So we can be able to use a G-clamp so that we can be able to fix this particular section here so that it does not topple or it does not overturn, right? Or you can even decide and bring a heavy mass on top of this so that you can be able to maintain it and keep it intact in that case. Yeah, so those are some of the precautions that you need to identify. So based on the experiment that is given, you need to know how you are supposed to approach question to do with safety precautions. I need also to mention another area here that you are like it. Describe the method the student could use not include a force meter. What else could have been done in order to determine the breaking force of this particular rubber band? What we can say, the force meter can be removed, and then once that's done, we add different masses on the rubber band. Keep on adding the masses gradually on the rubber band, and remember, when you add the mass, it will keep on stretching until you attain, you reach a point where you get a given mass that will make this to break. Once you have gotten that mass that makes to break, then you can now calculate the force that breaks this rubber band using the formula mass times gravity. So that is what you're supposed to do in that case. Explain why it's appropriate to repeat measurements. Remember, measurements are repeated so that we can have values we can be able to find average. And in that way, if you repeat measurement, you can be able to reduce the effect of the random error that can be caused by some of the changes in this particular experiment. Repeating measurement and values reduces the effect of random error by the variation of temperature in that case. The second experiment that was given to candidates is whereby a ball was dropped from some height, then it could bounce on the slope, and then they could be able to measure the distance x. So we are supposed to state control variables that could be taken here, because what is being changed is the angle of orientation or the angle of inclination, and then the distance the ball covers in the horizontal direction is measured. So what should be controlled? We can control the type of ball you are using, because if you use a different ball, it may bounce at a higher rate. But so to ensure that we don't affect these values, we have to ensure that the type of ball used is the same. Also, we can talk of the point from where the ball is being dropped. That position should be maintained so that the gravitational potential energy, the GPE, is maintained. Because if you raise it higher, it means the ball will have a higher gravitational potential energy. Then it will reach here at a higher speed, so it will bounce more. So, and that will affect this experiment. So the position from where the ball is released should be kept constant throughout. The height from where the ball is dropped should be kept constant, and because the height can affect the gravitational potential energy of the ball, so the impact velocity may vary, and that could affect the distance in the horizontal direction. One of the challenges that students said whenever they are performing such an experiment is that sometimes could be able to have a challenge to judge where the ball finally fall. You see, like for instance here. So the best way to do that maybe is to have a tray of sand, so that by the time the ball bounces and falls, it can stick in the sand, or if it bounces again, it can leave the dent, so that you can be able to see where the ball had fallen. So that's a measure that can be taken. So another concept that could be tested is the use of criticizing the data that is recorded. So when you are criticizing the data, what are the aspects you are checking? You check whether there is consistency in the number of decimal places. You check whether there is evidence for repeating the data collected, so that you can be able to identify the errors and anomalous errors there. And also check if there is a trend in the values that we have. But when you look at this question, there is no consistency in the number of 1dp. Here there's no number of decimal places. Here is one decimal place, is one decimal place. So there's no consistency in the data recorded in terms of the number of decimal places. You can also criticize by looking at there's no evidence for repeats here. Yeah. And if the data was for plotting a graph, how can somebody do 3 values and they want to draw a graph? Then this means this the data is not enough for a reliable graph, right? Yeah, so whenever you are criticizing, base your answer in the number of decimal places, evidence of repeat, and also the recording of at 20.5 degrees, you see it's 592. Something's wrong there. So you look at also the consistency and the trend that is followed. Explain one modification to reduce the error. That's what the one I mentioned regarding placing sand, or we can even use a camera to record the slow motion, so that you can be able to see where the ball landed. Yeah, so basically that's what you're gonna look at whenever you are answering a question on that. We have question 3, whereby we are told that a student determines the speed of ultrasound, and then you are supposed to describe the method to determine a single S accurately using a meter rule. How do you use a meter rule to make an accurate measurement? This is a question that's going to repeat in many papers, and I'm going to show you different papers where the same question is asked. The first thing, we have to ensure that the meter rule is clamped in position and is brought close to where you want to take the measurement. You clamp the meter rule in position, and then ensure that the meter rule is vertical. And how do you ensure it's vertical? you look at the set square. You use a set square to check whether the meter rule is vertical. In that case, you can see I've placed my set square here to check whether this is vertical. And when you are going to read the reading, you are going to ensure that you are reading perpendicularly so that you avoid the error of parallax. So whenever you're using a meter rule, for safety and for accuracy, you have to read properly to avoid error of parallax. And the zero mark of the meter rule should be coinciding to the lower part of the transducer so that you can be able to take the measurement. So these are the steps you need to follow. Clamp the meter rule, use a set square to ensure that the meter rule is vertical, align the zero mark, and then position your eye perpendicularly to measure the measurement. Ultrasonic transducers meter a pulse. So we were supposed to show that the speed is 330. This is determining the speed of sound. So we are told in one division is equivalent to 0.5 millisecond. So the time scale was set as 0.5 millisecond per division. So for us to know the time taken for this pulse to travel and to be detected, we shall count the number of divisions, and the number of divisions basically here was 6. So 6 times 0.5, we are going to get 3 milliseconds, and you have to convert millisecond to seconds by multiplying by 10 raised power negative 3. So meaning that we have our time. But remember, when we are talking about pulse being transmitted and being detected, so the pulse will be transmitted, it will reach the surface of water, then it will come back. So it will cover twice the distance. Then for us to work out speed, we are going to say what? We are going to say that speed is twice the distance. Speed is going to be twice the distance over the time taken in this case. And if you work it out, you are going to get your answer as 331.3. which is approximately 330 as it was given at that given point. So once we are done with that, another question that you really need to prepare on is calculation of uncertainty. Calculations of uncertainty, in this case, there is a situation whereby you'll have a single value and they will give you another question where you have multiple set of values. So in this case, when they have given you multiple set of values, it means you have to find the mean of this set of values, and then also you find the range of the values. So the first question you can see they have asked here is to find the mean, and the mean is the sum of all the values divided by the number of data that you're having, which is going to be 4. So if there is no anomalous point, remember sometimes you'll find a value that is very strange, you'll eliminate it or you'll assume it, you'll ignore it. But in this case, there's no anomalous point. We'll add all the 4 speeds and then divide by 4, and that translates what? That translates to 341. Then for you to determine the percentage uncertainty, when you are given data values, different number of values, you need to find the range. Then for you to find uncertainty, it will be a half the range. For this case, our range is 12. The largest value minus the smallest value was 12. Then a half of 12 is giving us 6, and that's going to give us our uncertainty. Then percentage uncertainty will be the 6, which is uncertainty, over the mean that you had gotten here times 100, and you're gonna get your answer being equivalent to 1.8%. I told one of my candidates should sign against here. The student must sign here. Why? You must always, anytime you're working out percentage uncertainty, you must give your answer to one significant figure or two significant figures. That's a rule. That's why I told that student to sign. Also, you should sign wherever you are, sign, so that we confirm that I told you, so that whenever you will make a mistake of writing 1.76, you don't have to come to blame me. So when you write 1.8 as your final answer, the examiner will be happy. Okay, all right, so let's move to the next bit. We are told the student modified the apparatus to determine the speed of sound in water you determine the speed of sound to be 1444 meters per second with an uncertainty of 4%, right? The accepted value, you are told the accepted value of speed is this value that is here, but the calculated value is this. So we are supposed to deduce whether the student's value for the speed of sound was consistent to the accepted value. So in such kind of a case, in that such kind of a scenario, what you need to do, because the calculated value is actually less than the accepted value, so what you are supposed to do, what you are likely or you are advised to do, or what you are supposed to do, is to work out the upper limit of the calculated value and check is the accepted value within the upper limit of the calculated value. If the accepted value is within the upper limit of the calculated value, then we can say it's consistent. And then now we can check. If you work it out, you are going to get your answer as 1502. So you can see you were given 4%, so I said 1 plus 4 over 100, so that I get the answer direct. Otherwise, you are supposed to work out 1444 times 4 over 100, you get plus or minus what. So this gave me direct, and this is consistent because the accepted speed is within the upper limit of the calculated speed, right? Yeah, so the next bit is a scenario whereby you are given a single data. In the question where we have just worked out uncertainty, we were given a number of values, then you were supposed to work out the mean, then find the range, use the range to find the uncertainty, because uncertainties have the range. But when you are given a single data like this, the approach is different, and these two questions must be in a paper where you are given about 3 data. You are supposed to work out percentage uncertainty, and another question will be there in this paper. In any physics unit 3 paper, you will have 2 scenarios you are finding percentage uncertainty, and we have talked about the other one. Now let's look at this. Here the least unit, least measurement that can be taken by this instrument is 0.01. That's the least unit because it's in 2 decimal places. So the least unit is 0.01 millimeter, and this is also known as what? It's also known as resolution. Are we together? So it means now uncertainty is equals to a half of times the least unit. This is what you are going to do, or a half of the resolution, and this is going to be 0.005. Then now percentage uncertainty will be 0.005 divided by the value you were given, which is 0.27 times 100. Then if you work it out, you are going to get your answer equivalent to 1.9. Remember, I told you to sign anytime you are working out percentage uncertainty, give your answer to one significant or 2 significant figures, nothing more than that. The student repeated the measurement of D at a different position and orientation. Explain another technique she could use to determine the accurate value of D. Check and correct the zero error by either subtracting or adding the error to reduce the systematic error. Don't say to eliminate, don't say to remove, we say to reduce the systematic error. So anytime you are given a question like this, another technique is about correcting the zero error in the measuring instrument. We have part B. We are supposed to explain why the fixed resistor is included in the circuit. In this case, is to limit the maximum amount of current that is flowing through the circuit, so that we can be able to prevent overheating in the system. Another type of question that you really need to prepare on is how to find quantities from graph and also drawing graphs. Now, in this case, we are saying using the circuit in B, the student investigated how the resistance between the resistance R between the point X and Y varies with length. And the relationship that was given here is R over L is equals to negative KL plus rho over A, where K is what? A constant. This is the symbol for resistivity. We have A as the cross-section area. Explain how the graph can be used to determine the value of resistivity. Now, remember the graph that was plotted is a graph of R over L against L. So meaning on the y-axis, we have R over L, x-axis, we have L. So which means, and since this is a negative sign, the graph will be sloping on to the left like that. I'm just trying to figure out the data that is given. But if you compare this graph that we have here and the graph of a straight line y equals mx plus c, we can identify that this section here, negative k, is corresponding to the gradient. So negative k is the gradient of that graph. And then resistivity of a cross-section area correspond to the y-intercept. Yeah, we are just trying to relate, comparing this given equation with the equation of a straight line. So we can say, comparing this, we can see that the y-intercept is this section here. Yeah, so since they are asking us how you can be able to use the graph, you are going to read the y-intercept. You read that y-intercept and you say is equals to P over A, and then which means that now not P, rather is rho, right? Okay, yeah, that's an international crisis, rho over A. So we can now therefore say rho is equals to A times the intercept, because now if you multiply A both sides, you're going to remain with rho, and then we can say rho can be calculated from the cross-section area times the intercept. Now, you are also going to fill in data on a table. Something that you need to realize, these are in 3 significant figures, 3 significant figures, 3 significant figures. You are calculating R over L also must be given in 3 significant figures. Be consistent in the number of significant figures. You check on this section that you have here, and then you record that to 3 SF. And also the units. The unit must be indicated on the area you have calculated. Most of the time, there is a mark attached to that. And how do we get that? We said because resistance over length, it is going to be ohm over meter. So that becomes ohm meter negative 1. And that is the unit that we have at that given point. Plotting, you plot the graph and use the graph to find the gradient is another concept that you need to know. And don't forget to write the correct units of the gradient. And the graph that we were supposed to draw here is this graph. And you can see our beautiful y-intercept is well elaborated here. I've indicated finding the gradient using a section of the graph, and make sure you use a big section of the graph equivalent to a bit longer, right? A bit longer in that, more than a half the line of the graph. Determine the value of rho. Of course, we had mentioned in the previous section that that is going to be what? That's going to be cross-section area times the y-intercept, and the y-intercept already we have seen is 21 from this part. You can see the y-intercept here is 21, so I can be able to use it down there. But we are also required to work out the cross-section area, yet we are given the diameter, so you have to convert this to meters, and then find the cross-section area to be 5.73 times 10 to the power negative 8 meter square. Work it out, you are going to get your answer 1.2 times 10 to the power negative 6 ohm meter, like that. Yeah, so if you have gotten value from this particular tutorial, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next video. Once the measurements have been taken by this type of instrument, anytime you are using a meter to measure the height accurately, you need to clamp that. You need to say clamp it in position and then use a set square to check whether the ruler is vertical. Then you can be able to take the measurement. And also, if you are taking a measurement, ensure your eye is positioned perpendicularly so that we can be able to avoid the error of parallax. Let me also mention another concept that is key when it comes to Unit 3 is calculations that you are going to be asked. One of the calculations you are going to be asked is mean of a quantity. So meaning you might be given different data and you are supposed to work out the mean, and to do that is the total sum divided by number of data. Yeah, for instance, if you are told maybe you have 2.0 centimeters, 3.1 centimeters, and 4.6 centimeters. So this is the data that you are given, and then you are supposed to work out the mean of that. To work out the mean, you are going to say mean is going to be 2.0 plus 3.1 plus 4.6 divided by how many are they? They are 3. So we are going to say this is going to be, if you add all this, you are going, this is going to be, this is 5, you add 4, that is 9.7 over 3 centimeters. So you can now put that in your calculator so that you can be able to get the answer there. So that will be 9.7 divided by 3, that translates to 3.2. You must give your answer correct to the number of significant figures that you are provided here, and that will be 3.2 centimeters, like that. So another question that can arise from here is to calculate percentage uncertainty. Percentage and uncertainty. To calculate percentage uncertainty, what you need to do in this case is first to work out the range of the data that we are given here. The largest value minus the smallest value, that will be 4.6 minus 2.0, and that will be 2.6 centimeters. Then now uncertainty is going to be a half of the range. If you are given a question whereby you are given different set of values, for you to work out uncertainty, it will be a half of the range. So in this case, our uncertainty becomes what? A half times 2.6, and that becomes 1.3. Then percentage now uncertainty will be the uncertainty we have, 1.3, divided by the mean we got. This mean that we have here, you must give it to one significant figure or two significant figures. So this is going to reduce to 0.41%. Your answer should either be one significant figure or two significant figures when you're giving the answer. Now, another type of uncertainty calculation you'll be seeing in your exam, and then you are supposed to calculate the percentage uncertainty. Anytime you are going to do a Unit 3 exam, you will have a question that has different measurements, more measurements, and you will have another question that will have a single measurement, and then you are supposed to work out the percentage uncertainty. So whenever you are given this one, you have to find the mean, then find the range, use the range, divide by 2, you get the uncertainty, use that uncertainty divided by the mean that you got to get the percentage uncertainty for that. But when you will be given a single data value like this, you are going to use the concept of resolution. The resolution of this instrument, we say resolution here, in the list unit this instrument that was used here can measure. Yeah, and this could be a micrometer screw gauge. Yeah, because it's in millimeters and it's also in 2 decimal places. So uncertainty in this case is going to be a half times the resolution that we have, and that's going to be a half times 0.01, and this is going to be 0.005 as the absolute uncertainty. Then for us to work out now percentage uncertainty, we are going to say this is going to be equals to the uncertainty we got, and the uncertainty we are getting from a half of the resolution, and the resolution is the least unit of measurement, and this is going to be 0.005 divided by 2.08, the measurement that was provided, times 100, 0.24%. And we have said that anytime you are writing percentage uncertainty, it has to be to 2 significant figures or to 1 significant figure. So make sure you sign against where you have written that you will always write it in 2 significant figure or 1 significant figure. Otherwise, if you don't do that, there will be an international crisis when your paper is being marked. I have a challenge on how to answer questions in this particular concept in Unit 3 Practical Physics. Check in the description. I've added a link where I've done a detailed past paper showing you how you are supposed to answer all the questions. In that particular video, I've really taken you through, I've given answers on how you are supposed to approach each and every questions. So check in the description so that you can be able to see more questions and the more concepts that are tested in this unit and how you are supposed to approach them. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next tutorial. Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, we're going to discuss IAL Unit 3 Physics. This is a master class that will enable you to understand how you are supposed to answer each of the questions that is set in such kind of paper. So as you are preparing for your exam, you'll be in a position to work it out. So we are going to look at this paper of May-June 2023, which is going to base a foundation of our analysis today, whereby we're going to discuss which kind of questions really get tested in that paper and how, and which is the best practice which can be able to earn you the best mark. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do further tutorials, you'll be notified. So we're going to look at this question here, whereby we're told in question 1, the examiner was testing whether you understand how to answer question to do measurement with a micrometer screw gauge. And in this case, what you need to understand is that a micrometer screw gauge, you need to read the slip scale, and also you need to read the slip scale, and then you read the main scale, the thimble scale. You need to read the slip scale and the thimble scale, then you add the two together. So you can be able to see at this given point we have this scale here, this 0, then 1, but when you have this particular mark at this given point, this means 0.5. So this 0, 1, 1.5. So that's why you can see I was able to record 1.50, then plus this thimble scale. You are going to check which is the mark that is coinciding with this scale and the thimble scale. So you see I placed a dot here that for this scale this is the mark that you need to read, and for this scale this is the mark you need to read because it's coinciding. Then which means this is going to be 20, 21, 22. So this scale here reads to 2 decimal places, so we are going to say 0.21. 2, then when you add the two together, you are going to get 1.72 millimeters. That is how you take a reading from a micrometer screw gauge. And something that you need to understand, usually this kind of apparatus, they have 0 errors, so you can be able to correct this measurement by either adding the 0 error or subtracting the 0 error, depending on the type of 0 error that is there. So if you are having a negative 0 error, you are going to add that error to this reading that we're having here. But if you are having a positive 0 error, in this case, you are going to subtract in that case. So it depends how a question is set, but for accuracy, you have to correct that error. The next question that you are going to be seeing in most of this exam is the question of uncertainty. You will never miss a question on uncertainty, and you'll be given 2 types of question for uncertainty. One where you have a single value. For instance, here we have read 1.72. That is a single value uncertainty. So in such kind of scenario, what you do is to work out uncertainty, and uncertainty is a half of the resolution. Usually resolution is the least unit of a measurement. In this case, since this is in 2 decimal places, the resolution is 0.01. So if you take that 0.01 divide by 2, you are going to get the uncertainty of this particular apparatus. Once you have that, then uncertainty now becomes 0.05, which is the uncertainty rather. Then percentage uncertainty will be the uncertainty that you have gotten here divided by the reading that we had gotten, 1.72 times 100, and that translates to 0.29 as the percentage uncertainty. Another question that will be there is whereby you are given different readings, and then you are supposed to work out the mean. Then from the mean you can be able to work out the uncertainty. So that question also will be there, but we are going to see it later. Now we are told to explain how she should reduce the source of error in this measurement of T. We know that this instrument probably have 0 errors, so need to check the 0 error and reduce this 0 error by either adding or subtracting, and this usually reduce the systematic error. But also we have another type of error which is called random errors, which could be as a result of wrong readings. So but 0 errors introduce systematic errors. Describe the way to the student balance the rule on the pivot I shown, recorded the and recorded the position of the center of gravity of the ruler, and then we are told to describe the method to determine the mass of this meter rule. So the way to do this is to use principle of moments, and we know that clockwise moment is equal to anti-clockwise moment. So if we have the mass of 20 grams, if it's attached to one end of that meter rule or meter ruler, then it means we can be able to support it or to pivot it at a given point if we know the distance from the pivot to the mass of 20, and also we know the distance from the pivot to where the center of gravity of this ruler is. Then we can be able to apply the principle of moments in order to work it out. So you can see, if we say clockwise moment equal to anti-clockwise moment, we can say m times x is equal to d times 20, and making m the subject of the formula will be able to get the mass of this particular ruler like that. So that's how you are able to determine the mass. And basically this is a paper that is testing practical skills that you learned when you are doing unit 1 and unit 2. In this case, also in question 2, we are told a student investigate the properties of a solar cell. This is the question that really gives most of the student trouble because this is unfamiliar kind of setup that was brought in this year of 2023. Explain the purpose of the convex lens, and the purpose of the convex lens was supposed to concentrate the rays to the solar cell so that the intensity of light can be increased. And how to do that? Because you see the lens is placed within the tube, So within the cylinder, so if there is a ray that passing that, it will go straight there. If there is a ray going this way, it will be directed like that. Then so basically our rays will be directed to the solar cell, and that's going to increase the intensity. Describe how two more ways to keep the light intensity incident to the solar cell, and I highlighted 2 points: keeping the solar cell at the same distance from the filament lamp, and also keeping the solar cell at the same angle to the filament lamp, so that most of the light is going to be incident. We have part B, whereby we were supposed to add an ammeter and a voltmeter in that setup. Remember, a voltmeter is usually added parallel to the component, and ammeter is added such that it's in series with the rest of the component of a circuit. So that's the concept that was being tested at that given point. Suggest the reason for using a fixed resistor. We are having a fixed resistor here, and the fixed resistor, when you are asked such kind of a question when it comes to unit 3, it's meant to limit the maximum amount of current that can flow in the circuit. So that is basically the reason you're gonna give if they give you a question like that, to limit the maximum current that flows in the solar cell. Describe 2 advantages of using solar cell to power a small water pump in a garden. Here we were just I think this is a kind of more of a IGCSE question that they brought here, because we talked about renewable resources and non-renewable resources. So basically that's what they were testing at this point. The solar cell do not emit greenhouse, so it does not contribute to global warming, and also it's a renewable energy resource, so it can be used forever. So I don't think there's any candidate really could have a challenge to do that. A student investigated the diffraction of electrons using electron beam as shown here, and the potential difference V accelerate electrons from the hot filament towards the graphite foil. The electron diffracts as they pass through the foil, producing ring pattern curve fluorescent screen as shown there. And basically, if we are doing also unit 2, this was to demonstrate the wave nature of electrons. Yeah, so the student used the vernier calipers to measure the diameter of the rings on the curved screen. Give 2 reasons why the vernier calipers are more appropriate for this measurement than the transparent ruler. Remember, a vernier calipers has a lower uncertainty. Yeah, has a lower uncertainty because it has a smaller resolution. A vernier calipers usually measure to 2 decimal places, so the resolution, the least unit is 0.01 centimeters. Yeah, so you can see it has a lower resolution, but for a meter rule it has 0.1 centimeters. So you can see this one has a larger uncertainty compared to the vernier calipers, which has 0.01. So basically a small resolution, hence has low uncertainty, and can also measure without parallax error. So whenever you are taking a measurement using a meter rule, chances are that you are likely to make a mistake. You are likely to read wrongly by positioning your eyes wrongly. So basically that is why we are saying here that this could result to error of parallax. Moving to Roman 3, we are supposed to describe how the student could measure the diameter of the ring accurately, and this particular point, remember, the student has used a vernier calipers. So the next thing that the student is going to do is to ensure that is checking the 0 error. Once he has checked the 0 error, then the student is likely to correct that error, and that is going to make the measurement a bit more accurate. At the same time, this particular student needs to take measurement in different orientation, and then now we will have multiple values of the measurement, then it can be able to make find the mean and that will reduce any random error that could be there. So we need to move to part B. We are told the student used the diameter of the ring to determine the wavelength lambda of the electrons. He repeated this for 2 more values of V, and the student also determined the value of a constant using the formula acceleration is equals to V, which is what? Kilovolts, yeah, and in kilovolts, lambda squared. We are supposed to determine the mean value of acceleration A, and basically this is the particular question I was really talking about. I was saying that every time you are going to do Unit 3 paper, you'll have 2 questions on uncertainty in the paper. One whereby you have a single value, and another one where you have multiple values. Then you are expected to work out the mean and then use the mean in order to work out the uncertainty. And basically that's what we are having in this case here, because we are told to work out the mean of A, and to find the mean, that is the average. Of course, you need to add all the values, divide by the number of values that you are having. Then once you have gotten that, also you need to work out the uncertainty. How do you get the uncertainty in this case? When you have multiple values, you take the largest minus the smallest. When you subtract them, you are going to get what we call the range. And the range now, if you do a half of the range, that now gives you the uncertainty in this particular case. And basically that's what I've basically done here, so that I can be able to get the mean. I got my mean as 1.22 times 10 raised to the power negative 18, and uncertainty will be the difference. What I did, I subtracted 1.32 and 1.11 so that I can be able to get the range, and that value I got as 0.21. I divided by 2 because 0.21 is the range. I divided it by 2 so that I get the uncertainty. So if you work out the uncertainty, you'll get the value equivalent to 8.6% as our uncertainty. Up to that particular point, we have covered the 2 particular questions on uncertainty that will be tested, and you will find that most of these exams, the questions will remain be the same, but you'll be given different case scenarios of the practical setup. If you are new to ProfLearn YouTube channel, consider subscribing so that in time I'm going to do more tutorials, you'll be notified. So we are going to move to the next part here, whereby we are told give 2 reasons why this is a better method. What is the better method that we were talking about, where the student repeated the investigation for different 6 values and then used those values to plot a graph. So if you are plotting a graph, remember when you are plotting a graph, you are going to use more data values, and if you are using more data values, their chances are that you are going to be more accurate. And also when you are going to draw the line of best fit, it's like you are performing another average, and from the line of best fit you can be able to identify anomalous points, and then you exclude it, and that is going to enhance the accuracy of your experiment. Then we are told that A can also be calculated using this particular formula, and then you are given values where you are supposed to substitute in order to find the value of H. So basically I try to make H the subject of the formula here, so that I substituted the value that were provided in order to get 6.52 times 10 raised to the power negative 4 joules per second. The percentage uncertainty in calculated value is 6%. Comment on the accuracy of the calculated value. So because H is Planck's constant, H is Planck's constant here, and we know that is 6.63, then what we were supposed to do is to work out the upper limit of the calculated value, and the upper limit is 6.92, and you can see now the value that I've gotten here is above 6.63 times 10 raised to the power negative 34 joules. So which means that the Planck's value that we usually know is between the lower limit and the upper limit of the calculated value. and this is now going to form a basis of us concluding that the calculated value is accurate. All right, moving to question 4, which is the last question. And remember, every time you are going to have a practical question, you are going to have a practical paper, chances are you must have also a question that is really analyzing the ability to draw graphs. So that's why now in this particular question that we are having here is a question that is going to test that skills of drawing graphs and also analyzing the graphs to find different quantities, as we are going to see. Now here we are told a student investigated the extension of an elastic cord. She hung 1.2 kg mass from the elastic cord as shown there. Identify health safety issues and how it may be dealt with. Anytime you are going to have Unit 3 paper, you must have a question that enables you or test the ability for you to be able to identify hazards or health issues as far as that experiment is concerned, and how you can be able to solve their problems. So in this case, you need to analyze, you need to analyze the apparatus that are there and see which danger can they pose to the person who's going to do that experiment. So if we can look at this, we are having an elastic cord. So chances are this elastic cord can snap and hit your eye, can snap and hit your body. So in that case, we need to protect ourselves against that, so we can be able to put on protective goggles. And also we have a 1.2 kg mass. Imagine that mass breaking from there and falling on your feet. Then it means that's an health measure that we really need to take place, because you need to do what? Put on safety boots so that you can be able to protect yourself and your feet from being what? Hit by that mass. Also, we can talk of the two stands that we are having here toppling, because if we are having look at the way the base was positioned, they were positioned the opposite side, so the likelihood of this mass being heavy and pulling these stands so that they can be able to topple. If they topple, the setup is spoiled. So the thing we can do, we can bring the aspect of G-clamp. We can fasten these using a G-clamp in order to fasten to ensure that it's a bit more stable. Let's talk of identifying two sources of uncertainty and errors in this experiment. Remember, whenever you are measuring the angle between here, it will also be a bit difficult because there will be introduction of error of parallax in the process of measuring that angle. So we can talk of parallax error when using a meter rule to measure the distance x, because you see there will be some measurement of some distance x here. So in the process of taking the measurement, there could be error of parallax. Also measuring the angle will be error of parallax resulting there. Suggest the modification to reduce the effect is to ensure viewing the measurement perpendicularly when we are taking the measurement, and also you can be able to take multiple measurements so that you can be able to find the average of those values. Yeah, so basically that is it. And then we are told explain why the graph of this, explain why the graph can be used to determine the value of G. So you can see here we are going to plot a graph of theta over 2 against 1 over x. So we can be able to use this formula here in order to find G, and this is the approach we are going to use. If you are plotting the graph, then the equation connecting the quantities cos theta over 2 is equal to mgk 1 over change in x. Now since there is no variable here, it means it's going to pass through the origin. So we are going to talk of a straight line passing through the origin. So if you compare and relate this equation with the equation of a straight line y equals to mx plus c, it goes without saying that this particular value that we have here, mg over k, because this is the value that is plotted on the x-axis, then it goes without saying that these quantities represent the gradient. So if you take this quantity mg over k and equate to the gradient of this line, which we can be able to work out of change in y over change in x, then we can be able to rearrange and make g the subject of the formula and say now therefore g is going to be k times the gradient divided by m, and that is how we can be able to use that. Whenever you are also given a table in this exam, ensure you are going to record your calculated value in the same number of significant figures as the raw data. So that is exactly what I did. And don't forget to include the units, because if we are finding 1 over change in x is going to be m raised to power -1 in order to do that. Another area is to ensure that you draw the graph using the correct scale and label the axes with the correct quantities and the units that are required there, so that you can be able to earn all the marks. So the next question that we are being asked here is to determine the gradient, of which you use change in y over change in x. Then you can be able to select points in your graph and ensure you use the points which are a bit apart, so that you use almost a half of your graph in order to find the gradient. And if we work out our gradient, we are going to get our answer equivalent to what? 0.078. And something that we need also to ensure whenever you have worked out this kind of question gradient, ensure you include the units of that gradient, because you are talking about quantities. Also that gradient probably will be having some units, and in that case we need to include the units there in order to earn all the marks. Lastly, determine the value of g, because we mentioned from the previous section that g is going to be gradient times the value of k, and then divide by the mass. And in this case, you can see they have given us the mass and they have given us the value of k. So possibly our work was there to just substitute in, and upon substituting we were to get 9.43 meter per second square, which is basically the acceleration in this case. And if you are new to Proflan YouTube channel, consider subscribing, and also you can be able to check more videos I've done in Unit 3. Check in the description, you'll have a series of other videos I've done, so that you can be able to see how this question you really usually get asked in each and every year. You will find that they are really very similar questions, but really tweaked to fit a particular context of an experiment that is given. I believe you got value from this particular channel, and if that's the case, you can also share this video to your friends, encourage them to subscribe. See you, and the best of luck in your upcoming exam.